Hello everyone, a very good afternoon to everyone. So we have been studying the power flow analysis. These are there are two widely common iterative methods to solve the nonlinear power flow equations that are Gauss-Seidel and Newton-Raphson's. We have covered all these things. Now from gate point of view, the most of the problems that have been asked from the Jacobian matrix. And this Jacobian matrix is a matrix of partial derivatives that is needed while solving the power flow problems using the Newton-Raphson method. So in today's session, we are going to solve all the problems of GATE exam that have been asked till now. So first have a quick recap that we have studied in the previous sessions. So we have compared these two, if we compare the studied methods that are Gauss-Seidel and Newton-Raphson method, we can see that Newton-Raphson is proves himself as superior in terms of convergence and the and independency, while this Gauss-Seidel method is better in terms of simplicity and computer memory requirements. This Newton-Raphson method does not depend on the size of system. Whether the size of system is big or large, this convergence time requirement is approximately same. And this Gauss-Seidel method is simple and it requires less computer memory. Now coming to the today's part that we are going to solve most of the problems based on this Jacobian matrix that we have seen in the previous sessions where uh, how this with the help of Jacobian matrix we solve the power flow problems using the Newton-Raphson method. So there are some points that we have to keep in mind while solving the problems of Jacobian matrix. If we don't keep these in mind, then you may feel confusion while solving the problem. So first and foremost thing is that in problem they may provided you the compensation techniques at the certain usage, and at the if these compensation techniques have been given, then with the help of that compensation techniques you have to determine that what are these type of buses. Like if a, if a, if at any bus where this static var compensator is connected, then that bus you have to consider it as a PV bus. And suppose if a bus is given where their shunt capacitor inductor are connected, then you have to consider that as a PQ busage. And in general, if a generator, if in a problem they mention that these are the certain amount is considered generator buses, then you have to consider including the slack bus. If it is mentioned that it is only the PV bus, then there is not inclusion of slack bus. And one thing also I forgot to mention here, if this reactive power violation occurs at PV bus, then that PV bus is converted to PQ bus. So it increases or decreases the PQ bus and PV bus correspondingly. And this formula for Jacobian matrix size is 2 into PQ plus PV cross 2 into PQ plus PV. How it is coming? Like with the help of power flow, there are four variables in power system. Anil, if you feel any trouble while understanding, then you can interfere me.
Okay, sir.
PQ and this voltage magnitude and this phase angle. And if we are knowing this voltage, magnitude and phase angle, then you can determine this active and reactive power flow. So therefore, these are the unknowns. These are the quantities that need to be determined using power flow analysis techniques like Gauss-Seidel, Newton-Raphson. So we have seen that the buses like mainly categorized whatever the widely commonly we see the buses. There are three types of buses. First, first one is slack bus, and then we are having PQ bus, and then we are having PV bus. So in slack bus, this voltage magnitude and delta del, that is phase angle, both are known. In PQ bus, P and that is load bus also. Here P and Q both are known. So unknown quantities are V and delta. So two quantities. And P bus, P and these are known. Unknowns that we found using power flow analysis. Unknown is only delta. So one quantity. And in slack bus, both voltage magnitude and phase angle is given. So j- no quantity are unknown. No quantity are unknown. Therefore, if we see the Jacobian matrix size, then we have to multiply the number. If certain number amount of PQ buses are present in the system, then you have to multiply with 2 because there are two quantities are unknown in PQ bus. That's why we multiplied in PQ with 2 while one quantity is unknown in PV bus. So we multiplied it by 1.
Sir, sir, you
Yes,
are saying slack bus, mode V and delta are known. Then, and you written here, no quantities are unknowns. But sir, P and power and active power and reactive power are unknown, sir, in slack bus.
yes, these are unknown that we find after solving the load flow problem. But whatever I am concerned here, that is the this active and reactive. What are the quantity that we solve using power flow technique, means using the Newton-Raphson method. So we find this voltage magnitude and delta, not the active and reactive power. After knowing this voltage and delta, you can find this active and reactive power using the power balance equation and so on. So our concern is that what we are finding using this Newton-Raphson method. So what are the things we found using Newton-Raphson method? This voltage angle and delta, right? Sorry, with this voltage magnitude and phase angle. So that's why I
Okay,
have
sir.
written like this.
Okay, sir.
Now let us solve the first problem. So here this first problem, that if you solve this problem, then most of the concept will clear based on the Jacobian matrix. So here this problem has been asked in GATE 2023 and it is of 1 mark. And these four options are given, so multiple single choice question. And here you are given with three buses, out of which 20 buses are generator buses and 25 buses with reactive power support and 15 buses that are with fixed shunt capacitors. All other buses are load buses. It is proposed to perform a load flow analysis in the system using NR method, Newton-Raphson method. The size of the Jacobian matrix is. So let us solve this problem. So total number of buses is 300 and number out of which 20 are generator buses. Total generator buses, that means PV buses. So it includes also the slack bus, because as I already told, if they are writing generator bus, then it is including slack bus also. So total number of generator buses is equal to 20. That means PV bus plus 1. 19 are PV buses and 1 is slack bus. PV bus plus slack bus. And this PV bus is 19 and slack bus, there is only one slack bus is in the system, so one is the slack bus. And 25 buses are the ones with reactive power support. So Anil, can you tell this 25 bus will come into PV bus or PQ bus? Anil,
PQ bus, sir.
number of buses with reactive power support. Number of buses with reactive power support is given as 25. So as I as I have shown you in the last slide, then this is counted to PV bus, that is generator bus, because to maintain the voltage quantity at its end, you need to have reactive power. Sometimes you may have need to external reactive power support. Inherently, it has exciter in the generator, but sometimes to maintain the voltage at the generator terminal, you have some reactive power support. So that's why this where the buses with reactive power support, external reactive power support, that is come into PV bus. So 25 is PV buses. Now number of buses with shunt capacitor. So it will come into PV bus or PQ bus. Anil, can you tell number of buses with fixed shunt capacitors?
PQ.
Yes, correct. Very good. So fixed shunt capacitor, that is reactive power compensation. So load bus only. So it will be PQ buses. Now we can find the total number of PQ buses and total number of PV buses that we need for finding the size Jacobian matrix. total number of PQ buses, that is 300 total number of buses minus 20 generator buses, so it will be subtracted, and with reactive power support, so it will also subtracted, that is PV buses. So total it is coming as 300 minus 45, so 255, and total number of PV buses, here I just want to mention so you don't get confused, excluding slack bus. So PV bus, this generator bus will come, and this reactive power support is also come, and from generator bus one will be subtracted, so it will be 44. Therefore size of Jacobian matrix will be 2 into PQ plus PV. So PQ is 255 plus PV is 444. So it is 510 plus 44. So it is 554. That is answer. So matrix size is 554 cross 554. So correct option is D. Did you understand, Anil?
Yes, sir.
Okay. So let us come to the next problem. So this is also a nice problem on Jacobian matrix. I think some problem is there.